Dear students, today we are going to learn about forces and pressure around us. This is the Unit 4 of the Grade 8 Physics syllabus. But for this presentation, we are going to talk only about pressure. The topics that we are going to learn today are definition of pressure, solving problems using pressure is equal to force divided by area, applications of the idea of pressure in our everyday life, understanding how pressure increases with increasing force, and how pressure decreases with increasing area in contact. So what is pressure? We have heard about pressure when referring to the following examples in our everyday life. Using a pressure cooker, hammering a nail in wood, inflating the tires of our bicycle, even climbing on very high mountains, checking the blood pressure, and cutting vegetables using a knife. Now let us consider this example. We can see that the nail has a pointed tip. The hammer hits the nail. A force is exerted by the nail on the wood. This force causes large pressure to be exerted on the wood. The nail is driven into the wood. This means a large force causes the nail to be inserted in the wood easily, and this is because there is a large pressure that is created on the wood. So we can say pressure is directly proportional to the force applied. Now let us observe the tips of the two nails that have been shown. On the left hand side, we can see that it is a sharp nail. The tip of the nail is pointed and sharp. So this nail is driven into the wood easily. What is the reason for that? You can see that the area in contact with the wood is smaller. Then the pressure exerted by the tip of the nail on the wood is large. So there is an inverse proportionality. So mathematically we can say that pressure exerted by the nail is inversely proportional to the area in contact. So it means when the tip of the nail is pointed and sharp, the area in contact is going to be small, and therefore the pressure exerted is going to be large. Now what happens if the tip of the nail is blunt, like in the second diagram? What would we expect to happen? Yes, you're right. The blunt nail gives a larger area in contact, exerts a smaller pressure, and therefore not easily driven into the wood or in concrete. So what should we do? What kind of nail should we use? Now, how do we define pressure? So far we have learned that pressure is directly proportional to the force. That is, when force increases, pressure also increases. Secondly, we have seen that pressure is inversely proportional to the area in contact. So when the area in contact decreases, the pressure increases. So we get pressure is equal to force divided by area. That is, if you want to calculate the pressure exerted, we need to take the force applied and divide it by the area in contact. We have also observed that the nail should be hit at right angles, that is perpendicularly to the wooden surface. So we can use these ideas to define pressure, and it is defined as pressure is the force acting perpendicularly per unit area. Now we will see what is the SI unit of pressure. We are going to use the defining equation, which gives pressure is equal to force divided by area. So the SI unit of pressure is Newton over meter squared, which gives Newton per meter squared. But this unit is also known as Pascal. So we can say that 1 Newton per meter squared is equivalent to 1 Pascal. Other units are kilopascal or hectopascal. So pressure is equal to force divided by area. Force is taken in newtons, area is taken in meter squared, so the unit is Newton per meter squared or Pascal. Now we will consider a worked example. A woman has a mass of 60 kilograms and stands on horizontal ground wearing flat shoes of total base area 0.05 meter squared. We need to calculate the weight of the woman and then the pressure she exerts on the ground. We will need the value of the acceleration due to gravity to be able to find the weight of the woman. So the answer is weight is equal to mg, that is mass times acceleration due to gravity, and this gives 60 times 10, that is 600 newtons. This is the weight of the woman, and it is also the force that she exerts on the ground. Now, pressure is equal to force divided by area in contact. Force is equal to weight is equal to 600 newtons. Area in contact is equal to 0.05 meters squared. So it gives a pressure of 12,000 newtons per meter squared. This can also be written as pressure is equal to 12,000 Pascal. Now let us see what happens when the same woman is now wearing pointed shoes, which we call stiletto heels. And this one is having a total contact area of 0.0002 meters squared. So what will be the pressure exerted on the ground in this case? So the weight is still the same, 600 newtons. Pressure is equal to force divided by area is equal to 600 divided by 0.0002 meters squared. And this gives 3 million newtons per meter squared or 3 million Pascal. So what do we notice? When the area in contact decreases, the pressure increases. Now let us see what difference does it make while wearing pointed shoes or flat shoes. We know that the pressure is inversely proportional to base area, or we can also call it area in contact. Flat shoes, having large base area, exert smaller pressure on the ground. so they do not sink in the ground. However, high heels having small base area exert larger pressure on the ground. They sink in the soil or sand or loose gravel while walking. This is why grass walkers are needed, are shown in the second picture. Now let us see some other applications of the idea of pressure in our everyday life. A knife, which is sharp, has a small area in contact. It exerts a large pressure, and therefore we can cut anything easily. Whereas when it is blunt, the area in contact is large, the pressure exerted is small, and we are not able to cut properly. When we are wearing flat shoes, it is comfortable and stable. It does not sink in the ground, so we can walk properly. A large truck has so many wheels. All these wheels together provide a large area in contact. So the pressure exerted on the road is smaller. It does not damage the road. When we buy a big bag like this one, we ensure that there is a strap that is broad. The broad strap ensures a smaller pressure on our shoulders. The thumb tacks have very sharp tips, but we have to press at the back, which has an enlarged surface area. So we can exert a high pressure on the notice board while the pressure exerted on our thumb is low. So we are not wounded by it. The quad bike has 4 wheels, and these wheels are broader. These wheels provide a large area in contact with the sand or muddy soil. Therefore, the quad bike can be driven properly without sinking in the sand or muddy soil. So these are some of the examples of the application of the idea of pressure in our everyday life. There are many more examples that you can look for. We have reached the end of this lesson. Let us summarize what we have learned. Pressure is observed in many daily life instances. It is defined as force acting normally per unit area. The defining equation is pressure is equal to force over area. The unit is Pascal or Newton per meter squared. Due to large pressure, high heel shoes sink in the soil, sand, or loose gravel. There are many applications of the idea of pressure in our everyday life. Thank you for your attention. Hope you have enjoyed the lesson.